we're evaluating integrals in the form of, I'd call this integral in the form of 1 over u. You have 1 over a variable expression in both cases. It's a definite integral because you have a definite starting and stopping point here. What's the antiderivative of 1 over x? It's natural log of x. Okay? Now, you might try to do that without using natural logs. You might try to do this. So don't write this down because I'm going to show you what could happen to you. You could call that x to the negative 1. And our rule for antiderivatives say you make that 1 bigger. So 1 bigger, that would make that x to the 0. Then you say you take your coefficient divided by your new exponent. So 1 divided by 0. But what's 1 divided by 0? Undefined. And that's where you should say, hold it, there must be a special rule for problems like this. And that rule is that the integral of 1 over x is natural log of x. So the integral of 1 over x is natural log of x. And then we put in our lower bound here, e and e to the 5th. Plug in the upper bound first, so we're going to do natural log of e to the 5th minus the natural log of e. Does anyone remember what natural log of e to the 5th would equal? 5. Yeah. One way you can think about it is natural log is base e. So what you're thinking is e to what power would give me e to the 5th? Right? Logarithms equal powers or exponents. So e to what exponent gives me e to the 5th? Well, e to the 5 would be e to the 5th. So this would equal 5. Another way to think of it would be to say, well, I know with logarithms I can move an exponent up front. What's the natural log of e equal? 1, yep. So 5 times 1 would be 5. How about the natural log of e? Well, we just said that. That's 1, right? 5 minus 1 is 4. So this answer is 4. As far as if you're going to do this on a graphing calculator, and you should be able to do this without a graphing calculator, okay? Without a calculator at all. But if you were going to do it on a graphing calculator, this is what it would look like. 1 over x, the graph of 1 over x looks something like this. Our lower bound is e, which is about 2.7. Let's say that's right here. Let's just call it e. And then e to the 5th, that'd be like 2.7 to the 5th. That'd be a much bigger number somewhere out here. So what we just did is found this area right here. That area would be 4. Okay, you just have to remember that integrals are represented by areas. Any questions about that? Okay, let's move on to this next one. The next one, you'd want to actually change that to x to the negative 2. You would not do an integral, you would not do a natural log here. Change that to x to the negative 2 dx. Make that 1 bigger, so that's x to the negative 1. Take 1 divided by negative 1, that's negative 1. Any questions about that? This is just your normal integral rule. Now let's rewrite that as negative 1 over x to the positive 1. Just using our algebra rule that if we move it to the bottom, it'll become a positive exponent. Plug in 4, so you get negative 1/4. Minus, plug in 2, you get negative 1/2. And if you're minusing a negative, that'd be the same as plus a positive. So it's negative 4th plus 2/4. 1/4. Yeah. Negative 1/4 plus a half is 1/4. So let me show you what this would look like if you were graphing it. 1 over x squared looks something like this. And you're going from 2 to 4. So 2 to 4. That area right in there between the x-axis and the curve is 1/4 of a unit.